this up. Anytime you go to light the burner, it doesn't come on, remind me to turn on the gas switch. Okay? I try to remember some of these things, but oops, it's different here. Oh, the other thing, when you have a box of matches like this, even when it's out of matches, save the box. Those other covered, the matchbox matches with the covered things don't strike as easily. And so if these strikers will work for any of our matches. And so it's a lot easier to use this than to use the booklet sort of thing. And people try to set their thumbs on fire with the booklets and everything else. So save these boxes, don't throw them away. Okay, so the first thing I did was I got my boiling water bath and everything started. I get my book out of the way so it doesn't get slopped up. I need more working space. Well, nobody wants this there, I'll put it over here. But the thing I do need is my instruction manual. Which is in here. And I open it up to page 162, right after the flow chart we had yesterday, which starts procedure 1, the precipitation of the silver group. And I get a clean test tube. A dry would be good because one of the problems is you don't want to add a lot of water, because the more water you have, the more likely you'll lose the lead. So I'm going to get a dry, clean test tube, or mostly dry. I know it's pretty hard to dry these things out. And it says, put in 5 drops of the solution to be analyzed. We're going to start with known 1. I get the bottle that the late instructor put out for me, and it says known 1. And it says use 6 drops. Boy, I'm confused already. The book says use 5. The instructor said use 6. What are you going to do?
See what the book says?
Use 6. That makes sense to me, especially since when I did that calculation over there, I based it on what? 6 drops. Right, that's why. Okay, so I'm going to put 5 drops in a 3-inch test tube. 6 drops. Oh, okay. I read the book instead of the dropper bottle. Okay. 1, 2, 3, 4, 5. Come on, 6. Okay, one of the things you should do is see how far it fills it. Notice it filled it about like that, because lots of times you'll want to add 5 or 6 drops, and if you miss counting, you can still be close enough. After all, this is called qualitative analysis. It's not quantitative, so the actual number of drops is not critical. You just don't want to go too far on one side or the other, because then you won't get enough precipitate or something else will happen. So if you happen to get 7 drops in here, it's not going to kill you. It's not going to make a big difference. When I'm filling them back there, the droppers in each of the different unknown bottles have slightly different volumes per drop. And sometimes one person will get about this much and the other person gets slightly more or slightly less. That's just the variation in the dropper size. When I said 20 drops equals 1 milliliter, for some droppers it could be 18 or 19 drops per milliliter. Other droppers it could be 21 or 22. In the old days, we used to have the students calibrate their droppers so they knew how many drops per milliliter. We don't do that anymore. We more or less emphasize quality. Okay, so I've got this part. Then it says, and here's the first thing I'm going to change. It says add 5 drops of water. Cross that out. Later in the semester, when we do this procedure again for the general analytical scheme, I'll say put it back in. But right now we're going to cross it out because we don't want to lose the lead. Okay. And it says add 2 drops of 6 molar HCl. So I'm going to hold my test tube like this, so that if I miss with my drops of HCl, it'll hit my wooden test tube holder instead of my finger. Okay. Or if I were confident I'd do it there, I walk over here and I read these things. HCl, H2SO4, HNO3, NH3, that's the only HCl. Oh, by God, it says 6 molar. Now, HCl, aqueous, or hydrochloric acid, and sometimes when you can't read the labels anymore, ask me to put a new label on and I'll eventually get to it. What happens is the labels last about 2 or 3 months and then they start getting smeary and whatever. And I think the latex gloves that I have everybody wear contributes to that problem. But it's a gas dissolved in water. And so we always loosen the top. Because if we don't loosen the top, it builds up pressure and it starts dripping. Okay? So the top is always loose. And some of these we loosen, some of these don't. If you really don't know, just loosen it. The next person can tighten it. But if you try to get drops out of there with the lid loose, the air goes out the top and it doesn't push liquid out the spout. So you tighten this down. And then you usually start the first drop over the sink because you're working at the sink. Because the first drop sometimes comes out as it came out nice and even. 1, 2. You saw what happened, the same thing you saw over there when I did it with the, whatever that machine was called, visual presenter. Mix it up. There we go. Now if I wait about 3 or 4 days, it'll all settle out. But I have a centrifuge here. Now this centrifuge has 6 wells. And numbered 1, 2, 3, 4, 5, 6. Yep, everything's 6. Must be the magic number. Okay, the point is, if 2 people come up at the same time and you have about the same volume of solution, you can put yours in one and the other person can put their sample in 2. And that way we could actually accommodate 6 people at one time. I don't think you want to do that much. And one of the things is, we did happen to get funds for 2 new centrifuges. So last semester we were struggling with 4. This semester we'll have 6. Okay. Now these have a little timer switch on the front. If you go clockwise like this as I'm looking at it, or as you would be looking at it when you're doing it, it has a timer function and it shuts off. You don't want to bother with that, and those switches on a couple of them have worn out. So what you always want to do is turn it to the left. That means it's permanently on, but there's a little micro switch in the hood, in the opening of this cover. If it's on the permanent on position, notice it starts up when you close the lid. And it stops, and unfortunately, the ones with the automatic brake cost about $4,000 or $5,000. These cost $1,200. So guess what we ended up with?
It's called
without the automatic brake. So what do you do about that? You can wait, but some of these things are going to get done a little faster. At each one of these, we have a little eraser. And it has a little black rotor here. If you gently touch the eraser to the rotor, it stops it. Don't put it over the top where the glass is spinning around or it'll cut up everything. And you'll lose your sample to boot. So you gently want to put it on the side. Before I ask people to wear those plastic gloves, I used to just say you put your finger on either opposite sides of the rotor and slowly squeeze. But with the rubber gloves, it really grabs hold and pulls the gloves off and pulls your hand all over the place, so that doesn't work. And that brings to mind the story of one, and he was really a good student, he was just inexperienced. And instead of turning off the centrifuge, and it was those old-fashioned kind that you see here, I just left it out here for an example, he grabbed the rotor as hard as he could. He was standing there hanging on for dear life trying to get the thing to stop. And after about 2 times I sort of told him, you know, it's a lot easier to turn the switch off. He was really, figured he had to stop it with his bare hands, and he was really holding on to that thing. Okay, now if you just put in one tube by itself, it's going to unbalance this. These do spin at a high rate of speed. You'll get the thing vibrating and making a terrible noise. So you always need a counterbalance. Okay, I'll turn it down a little bit. By the way, one of the accidents that happens a lot, which is why it's nice if you're working with a partner, these things run out of water. They're Pyrex. If they run out of water and you squirt some more water in, they crack right away. And then you get to buy one. So what you want to do is, as the water level gets down near the bottom, whoever's looking at it, just take your wash bottle and squirt some more water in there. That way you won't run them dry and you won't run the risk of breaking them. Okay, so I'm going to put my counterbalance. This is a test tube. Now some of the test tubes are a lot different in size, so try to pick 2 test tubes about the same size. And then I'm just going to put a little bit of water in here, with the same volume. Those have about the same volume. So if you have a lot of liquid, you have to put more water in the counterbalance, less water in the counterbalance. The other thing we have, which I will put out when we start, is a big box of old test tubes. One of the things that experiments we do, we use sodium fluoride, and it etches the test tube, and it gets all cloudy and you can't see through it. Those make great counterbalances, because when you pick up a cloudy test tube, you'll know it must be your counterbalance. When you pick up 2 test tubes like this, especially if you have a small amount of precipitate, or that particular ion wasn't there and you didn't get any precipitate, sometimes you'll mix up your counterbalance with your sample. And I've noticed, and people say, no, that wouldn't have happened to me. But over the years, there are always a student or so, they're doing great, they're going along, and all of a sudden, about the 3rd way through the experiment, they don't find any other ions. Why? Because they started analyzing their counterbalance where they had distilled water, because they mixed up their test tubes. And the same thing, if 2 people come up, you should always remember where your test tube is, so you don't start analyzing whoever's sharing the centrifuge's test tube. Okay, so when I'm doing it by myself, I always put the sample in number 1, counterbalance in 4. If 3 people come up, you can do 1, 3, whatever it is, 1, 3, 5. I do there in a sequence. Okay, then I'm going to close the lid, because I have this on permanently on. That's the most convenient way. And it starts spinning. It takes about 15 to 20 seconds to come up to speed. Now, you should stay close by your sample in the centrifuge. Because one of the things I say, if you're waiting to use a centrifuge and you see it standing there spinning away, just turn it off and use it. Ignore whatever's in there. And throw it away for all I care. Of course, people will start complaining, but that's their problem. Okay, that's up to speed. This has a little latch that you push. I think the other ones don't have a latch. And I'll use my little eraser to stop. And there's my nice pellet of precipitate in the corner. Okay, just the way I showed you over in the, oops, I forgot my test tube rack. How could I forget a test tube rack? You can't work without a test tube rack.